Hello students, in this class we'll see the nature of roots. It's a topic under quadratic equation chapter. The quadratic equation will have roots which may be real, distinct, real and equal or maybe imaginary. It depends on the b square minus 4ac value. What do you mean by b square minus 4ac? It is a discriminant. Okay, let's see the topic nature of roots. The standard quadratic equation is of the form ax square plus bx plus c equal to 0. This is the quadratic equation. Here, discriminant, it is denoted by small triangle symbol. It is b square minus 4ac. If discriminant is greater than 0, roots are real and distinct. When I say distinct, it is different, unique. If determinant is less than 0, roots are not real. What do you mean by not real? It's called imaginary. Okay. Why imaginary? We'll see it while solving the problems. The another condition is if discriminant is equal to 0, then roots are real and equal. Okay. These are the three conditions um, to find the nature of the roots. Okay. Then there is a formula to find the roots for the quadratic equation, which is called Sridhar Acharya formula, which is called x is equal to minus b plus or minus b square minus 4ac by 2a. For the as per the revised syllabus, there are no questions related to find the solution or find the roots by quadratic formula method. Okay, this is called quadratic formula. Okay, x is minus b plus or minus b square minus 4ac by 2a. So if you observe here, b square minus 4ac is under root. Okay, so coming to the nature of roots, three use cases, three classes. B square minus 4ac is greater than 0 means root determinant greater than 0, right? So we can find it's a positive number. In the determinant, if it is less than 0 means root will have negative number. Say for example, root minus 5. We don't, it is out of scope to find the value of root minus 5. So we just say roots are not real. When determinant is equal to 0, square root of determinant is equal to 0, then we get roots as equal. Okay, we'll see how to find the nature of the roots for certain equations. Let's see the exercise questions. See, under first main, there is a question 2x square minus 3x plus 5 is 0. How do you find the roots? Nature of the roots. See, find the nature of roots. If exist, if real root exists means the discriminant value should not be less than 0. That case exist, then find them. So here on comparing this with ax square plus bx plus c, we get a equal to 2, b equal to minus c equal to 5. Okay. Then find the determinant. B square is equal to b square minus 4ac, that is b square is minus 3 whole square minus 4 of 2 of 5, 9 minus 4 to the 8, 8 5 is 40 minus 31, which is less than 0. Therefore, see, they have asked if the real root exists. Here, the roots are not real, right? Therefore, roots are not real. So, no need to find them now because imaginary roots they are now. So, we cannot find the imaginary roots at this moment. Okay, this is first question. Let's move to the second question. 3x square minus 4 root 3x plus 4. 3x square minus 4 root 3x plus 4 equal to 0. Okay. Here on comparing, we get a equal to 3, b equal to minus 4 root 3, c equal to 4. How do we get these ABC values? Means it is on comparing with ax square plus bx plus c. Find out the discriminant b square minus 4ac. B square is minus 4 root 3 whole square minus 4 of a of c. When you extract the values of ABC, please consider the signs also. Don't ignore the signs. So minus 4 root 3 whole square minus, no, it means minus into minus plus 4 square is 16, root 3 whole square is 3. So 16 3 is a 48 minus 4 3 is a 12, 12 4 is a 48. Here it comes to 0. When determinant is 0, therefore roots are real and equal. Please understand, you have to write complete. Don't just write real. You have to write real and equal. Then the roots can be found by the formula which I said just now, minus b plus or minus b square minus 4ac by 2a. Here, when this part is 0, because b square minus 4ac is 0, then the root of 0 is 0. So the roots will be minus b by 2a only, 2 times. Because it's a quadratic equation, it should have 2 roots. So ignoring this part, roots are minus b by 2a. Minus of minus 4 root 3 by 2 of 3, that is 4 root 3 by 6, 2 2 is a 2 3 is a 2 root 3 by 3. Okay. So if we found the roots, you have to write 2 times the same thing because here roots are same. Understood? We'll move to the next question. The last in the first main, 2x square minus 6x plus 3 is 0. On comparing it with ax square plus bx plus c, we get a equal to 2, b equal to minus 6, c equal to 3. Then determinant is equal to b square minus 4ac. Substitute the values and find them. Minus 6 whole square minus 4 into a is 2, c is 3. Open the bracket, minus 6 into minus 6 is 36. Okay. Then minus 4 into 2 into 3. 4 to the 8, 8 3 is a 24. Upon subtraction, we get 12, which is greater than 0. Right? Therefore, conclude roots are distinct, real and distinct you can write, or distinct and real also you can write. So in this case, you have to find the roots. When it is greater than 0, you have to use the formula itself. X equal to minus b plus or minus b square minus 4ac by 2a. So x equal to minus of minus 6 b square minus 4ac we have already found it. Don't substitute again. Separate a, c, b. Just write its value. 2 into a is 2, right? A is to 2. So minus into minus plus 6 plus or minus 12 can be written as 4 into 3. 4 is a perfect square. See, root 12, 4 into 3 becomes 4 into root 3. These are all solid properties, okay? So root 12 can be written as 2 root 3 by 2 into 2, 4. That is, x is 6 plus 2 root 3. Okay, let's take the common thing out here. What is common if you observe? 2 is common. 2 3 times the 2 came out already. So we did not write 2 here. 2 1 ja 2 2 ja. So for x is 3 plus root 3 by 2, one of the root. 3 minus root 3 by 2, another root. Okay. plus or minus is there, no? So you just split it so that we get the two separate roots. Clear? If the roots, if the determinant is greater than 0, you have to use the formula itself. Okay. Let's move to, based on this nature of roots, we have another set of questions. If you see in the second main, find the value of k for each of the following quadratic equation so that they have two equal roots. They said equal roots means b square minus 4ac is 0, right? You have to equate it to 0. Let's find it. First write the equation 2x square plus kx plus 3 equal to 0. Okay. On comparing it with ax square plus bx plus c, what we get? A is 2, b is k, c is 3. Remember, x coefficient is k, which is b here. Therefore, this equal b square minus 4ac. They said roots are equal, then we know b square minus 4ac should be equated to 0, right? So substitute it here. So 2 square minus 4 of, sorry, b square is what? K, right? B is k. K square minus 4 of a is 2, c is 3. So k square is equal to, just multiply and transpose to the right side. 4 to the 8, 8 is a 24. Okay. So k is equal to plus or minus root 24. You can split it again. 224 is nothing but 4 6 is a 24. 2 root 6 will come. So plus or minus 2 root 6. So k is plus or minus 2 root 6. Understand? Understood, right? So when they said the roots are equal, then don't just find b square minus 4ac. You will end up with the expression, not the equation. So you have to make equate to 0 so that you find the unknown in it. Okay. Let's see the another question here. There is another question. Second one. Kx of x minus 2 plus 6 equal to 0. Here kx of x minus 2 plus 6 equal to 0. Just open it because it is not in the standard quadratic equation form to extract a, b, c, right? So multiplying kx square minus 2kx plus 6 is 0. This is in the form of x square plus bx plus c. On comparing it, we get a equal to k, b equal to minus 2k, c equal to 6. When you extract the values of a, b, c, just leave x square, write everything behind x as a, leave x, write everything behind x, means that term, particular term, not till x square, okay, as b, and c is 6 plus constant, it is plus. Then since they said roots are equal, we make it equal to 0. So b is minus 2k whole square minus 4 into a is k, c is 6 equal to 0. Minus 2k whole square is nothing but 4k square minus 4 6 are 24k equal to 0. What is common here? 4k common, k minus 6 is 0. Okay. Now, these are already in factors form. Each of them equate to 0. You get the value. 4k equal to 0, k equal to 0, one of the value for k minus 6 equal to 0, k equal to 6. They have asked us to find the k value. So these are the values. Clear? This is where, this is how we find the nature of the roots for a given quadratic equation. Based on that, we find their zeros. Okay. Thank you.